you have done PICUP things in the past. If there is anyone who hasn't, welcome. We're very, very happy to have you. So PICUP is the Partnership for Integration of Computation into Undergraduate Physics. Although if we have any high school physics teachers, we're very welcoming to you also and glad to have you here. Be aware that the current project that we have is being funded by a grant from the National Science Foundation. So we're appreciative to that support. And also be aware that once we get underway here, for the presentation parts of today's workshop, we are planning to record that. So be aware that should be recorded. The way the workshop is going to work for the week is that on today, Tuesday, we're going to be meeting here in this Gather Town space, and there's going to be some presentations that we'll talk a bit more about in just a minute. And then tomorrow will basically be office hours. So getting back together in small groups tomorrow, very informally. And then on Thursday, we'd like to have you present something very briefly, just a few minutes of telling the group what it is you're thinking, what it is that you're working on or planning to work on. Again, very brief. Don't feel pressured about that, but we'd like to give you the opportunity to share. In terms of this space that we are inside of right now, anyone who's on the green carpets at the very top of the screen, those people are broadcasting to the entire room. If you're on one of the individual carpets that say red group, blue group, lime group, orange group, etc., then you are talking to everyone who's also on that carpet with you. So the carpet acts as a room to be able to talk inside of small groups. And then in addition to that, if you're nearby anyone in terms of proximity, you also can interact with people if they're nearby you, like you'd interact with someone nearby you in an actual room in real life. So that's sort of how the Gather Town space works. One important thing to be aware of is at the very bottom of your screen, you should see a little signpost. And that signpost is called the info board, and it has some important information on it. And I'm going to attempt to share what's on that here. And so this is a first sharing attempt. Hopefully you'll be able to see a list with a few items. One other thing we just added at the top of that is a link to join the PICUP team on Mattermost, which is a communication software similar to Slack. So the very first thing you'll see on there is joining the PICUP Mattermost team. So we encourage you to do that. When you do that, just post a message of some sort, say hi so we can see you're there, and then we can add you to the specific channel for this workshop on Mattermost. The next thing, providing contact information. If you want to give your contact information to the rest of the people who are here today, feel free to do that. And then the next link is for the website, specifically on the PICUP website for this virtual workshop. There is a Google Drive folder that will have shared materials in there. So that's what that next link is. And then the next thing after that, for Thursday's presentations, we are going to collect, and we're not doing this yet, but you'll have an opportunity to sign up for a time on Thursday. But then below that is something that we do need you to be doing sooner rather than later, is later today, we're going to get into groups. And for those groups, we'd like to try to separate them based on what you're actually interested in. And in order to be able to do that, we need to be able to collect what are sort of the main areas of interest that people have. So where it says describe your interest here, that is a link that takes you to a page where you can put a bit of information about what it is you want to be accomplishing or what you want to be hearing about this afternoon, what you want to be getting help with. So please provide that information sooner rather than later so that we can get those groups formed that we'll be making use of this afternoon. For the other facilitators, is there, well, maybe one more thing that I'll say and then check to see if I forgot anything. So for today, we're going to have 3 different sessions happening today. So the first session, we'll hear from some different people with the goal being to try to inspire you to say, wow, that stuff is really pretty impressive. I need to find out more about it. So that's the goal of the first session. The second session is to actually give you some information about the nuts and bolts of how this stuff works beyond just the inspiration. And then the third thing is we'll get into small groups using these different rugs here with red group, blue group, etc. Okay, so from the other facilitators, anything that I missed before handing it over to Steve? Okay, well, with that, Steve, you can take it away.
Okay, hang on.
Steve, do step on the green. Yep.
Yeah, I got to get up here on this little green carpet so everybody can hear me. So my name is Steve Spickelmeyer from the University of Indianapolis. Todd and Andrew and I have been working feverishly to get Trinket whipped into shape so everybody can use it. So I'm going to just take a minute to show you folks the current state of affairs. Let's do this. And I've got infinite. Okay, can you folks, are you seeing my screen at this point? Do you see the PICUP? Yeah, okay. I don't know who I can hear. Do you have to be on the carpet for me to hear you? Anyway, okay. So this is trinket.gopickup.org, and this is my particular account. You can see it looks a lot like trinket.io. I've got another tab here. Did that switch to trinket.io for you? Fortunately, I can't see anybody, so I'm assuming it did. Okay. Do I need it? Okay, I guess I'm not haven't quite mastered the interface yet. So anyway, this is trinket.io, and I just wanted to point out here that if you've got trinkets already that you've created at trinket.io, that you can download all your trinkets from trinket.io and upload them into trinket.gopickup.org. That there's a mechanism to get all your stuff off of trinket.io. And it's a little bit challenging to find, though. What you do is you go to your profile, you choose My Settings, you go to Data, and then you can click to download all your trinkets. You can see I've done this a couple times. Once you click this button, it builds an archive that you can then go and download. Now, these are all expired because I did it a long time ago, but you'd be able to come back and download this archive for some period of time after you exported all your trinkets. The other thing you might have are some courses. So here's a bunch of courses that I have either created or have access to, and you can go to the course menu and then click download course pages. And that brings up a dialog. And what you want to do is to download the source files. And that goes through and it takes all the markdown files in your course. It takes all the images that you've attached to those markdown files and uploaded into trinket.io. And it grabs all the actual trinkets that are tied to that particular course, and it puts them in an archive and downloads that archive for you. You can upload the course into trinket.gopickup.org, and it will extract all that stuff and load it into the new Trinket server. So that's one thing. Okay. Now maybe, let's see, if people have questions or anything, how am I going to know about that? Is that something I'll be able to hear folks ask or see?
We'll watch the chat, I guess, and I think people can raise their hands.
Anything, so I don't know. Okay.
We'll keep an eye on chat.
Okay, I'll keep the chat. Well, I can't because it's because of the way I'm sharing. I block. Okay. Somebody step into the room and get my attention if there's a question or something that needs to be addressed.
Yep.
But this works just like if you're familiar with trinket.io, this works exactly almost exactly like Trinket.io. You can create new courses. You can import a course. If you create an archive from Trinket.io, you can import the archive here. I don't know if it's been merged yet, but there's going to be a feature where on the My Trinkets page, you can upload the zip file from Trinket.io, but that feature, we've got a bunch of features that are in the pipeline that haven't been merged yet, and that's one of the features. But let me just point out, there are two kinds of trinkets that we support at the moment. There are Python trinkets, and there are web vPython trinkets. They're basically two different kinds. Some folks also know these as GlowScript trinkets, but the name has been changed to web vPython. And so if you create a new trinket, I can name it. So my new trinket. And then you can do all the web vPython things, like I can make a sphere. And something like this. I don't know, that looks like a web vPython program. So that's going to create a blue sphere at the origin. Then it's going to set its X position to 0, then 1, then 2, then 3, then 4, like that. And it's going to update 2 times a second. So I'm going to save that guy, and then I can run it. And while I have too many languages. How about that? There we go. So there goes the sphere. So anyway, web vPython, if you're familiar with that language, it's really Python, but with some 3D capabilities. That's kind of how that works. And then let me illustrate. Oh, I forgot to, if I save it here, let me run it one more time. If you run it and then save it, it'll capture the screen when you save it, and it will use that as an image so you can help remember which trinket is which. Let's go ahead and make a new Python trinket now. So this is Python 3. So you can do all the Python 3 things. So you could say, I'll do import NumPy as NP, maybe import matplotlib, pyplot as PLT, and then let's see, x equals NP, all the NumPy things, all the matplotlib things. It's got pandas. It's got most of the standard packages, SymPy, and so on. And
Steve,
then, yeah.
Can you show off the superpower, the vPython in Python 3?
Oh, yeah, sure. Yeah, why not? So I'll make a green sphere, and then let's do this. Let's something like that, maybe. And then make this one go a little bit faster. But the other thing I could do is to make a plot. So we could say, it's kind of silly, but so the point is you can mix matplotlib and vPython in funny ways. So that should work, I think. Let's, oops, that's the wrong way to save. Mix the Python and NumPy, etc. So save that guy. And so when I run it, it's gonna, I didn't spell it right, matplot. There's no pl. Okay, so there's the sphere and there's the plot. The point is they are together, and so you can mix and match as needed. This is interactive matplotlib plot. You can save it and so on. So yeah, it's fun. Now, one nice thing about this relative to Trinket.io is that this is all running in your browser. So we're not having to support server-side computation. It's using a technology called WASM through the Pyodide project to run everything in your browser. So that's really cool. Okay, and now maybe I could drop the screen and Andrew could show off his variable explorer and debugging capabilities that he's developed.
Okay, yeah, I will put my screen up. Oh, shoot. Hopefully I can do this. Okay. So, all right. So one of the things, I guess, really quickly I wanted to show is that this is a glow script thing that I just wrote. My version of Hello World is just literally putting a sphere on the screen, and you'll notice that when this was done just like Steve showed, where I started with a new trinket and I just did a web Python, and all I did was write this in that in there. And after you save it, after you save the web Python, you get the typical windows, the result, and the instructions that you've seen if you've ever used Trinket before. But if you do the same thing with a Python one, I'm going to pull up, this is a Python script that I wrote. Not only do you have the result and the instructions, but you also have this new tab over here, which is variables. And so when I click on variables, this is a variable explorer, and well, I don't know if it's enabled on here. I'm going to show you the step through debugger, which may not be completely enabled yet. So this thing runs, and after it runs and shows the results of whatever it is, this is just a demo thing. It's not actually doing anything very interesting, but you get this variable explorer over here, and it has all the variables that you might be interested in. We decided to break out the functions and classes, and if you really want that, you can also have that. So down here are the functions and classes. But I guess on the Go Pickup thing, the step-through debugger is not quite yet enabled. It's one of those features that's coming soon, but I can show you a version of it. So this is demo number 2. I'll do this, I guess, whatever, it's fine. One of the things, actually, I'm gonna just try to quickly reload this and see if it just comes back up. Yeah, okay, cool. All right, so one of the things with the step-through debugger is that it's not super critical to understand this for like students or whatever, but the way that it works is that it actually runs the entire script before the debugger like starts, right? Or the step-through. We're calling it a step-through. I keep calling it a debugger, but I decided to name it step-through because it's not a fully function debugger, but whatever. So if I hit this, and you see the little text there, it says records your program running from scratch as a standalone script. Nothing carries over from earlier runs. Then let's use, so this, the way it works is it has to run through the whole thing before you can start stepping through it. So when I click this, because there is a very large loop over here, it's going to take a little bit of time to go through it before it comes up. So, I mean, that wasn't too long, but it was something. All right. So now it only records the first 5,000 steps, and apparently I've got more than 5,000 steps in here. So, you know, I don't think you want to watch me go through all of this, like, you know, 5,000 times, and then it's not even going to get through the whole loop, right? But you do see that every time I click on it, the variable, the two variables change, they update themselves, all right? But if you have a very long loop like this, you can actually click on the line number over here, and then when you do the step through, it starts right at that point, and then you can just step through that. So now there's only 8 steps left to do, and the variables update as you go through it all. So anyway, I know that was like kind of quick, but that's the basic idea. So we have both the variable explorer and a step through mechanism to help you you and your students troubleshoot things.
All right, thank you guys. So just to make sure everyone's clear on this, what Steve and Andrew were just talking about is a lot of software engineering that they did with an enormous amount of help from agentic programming, in particular Claude that both of you were using, correct?
Correct.
And
yeah.
Yeah, on top.
and Todd also, yeah, that's right. And so just to sort of put this in a little bit of context, so here's 3 different companies that all provide analogous services. That the platform that the company Anthropic has is called Claude Code, and then it has different models that have different amounts of smartness. And you'll hear some more a little bit later about the details of Claude, but there's other companies also that have analogous platforms, and they also have models. And I'm going to show you just really briefly a couple things that I've done recently that at our in-person week-long pickup workshop about a month ago, I was inspired by these guys that, man, I really need to try this stuff. And was absolutely had my mind blown by what it's able to do when you give this process of agentic programming a try. So we just wanted to help you be aware of what can actually be done and find out how it works so that you know in terms of what your students might be doing in the future. So I'm going to show a couple of things really quickly. So this was the very first thing that I did when I decided to give this a try. Is our school uses Blackboard for our LMS, and it takes an enormous number of clicks in order to do anything. So I made this routine with the help of, initially I was actually using Google's version, which is called anti-gravity. So this thing pops up every morning, and so I'm gonna use that this semester, and it asks if I want to download from Blackboard. And if I click download, what it does, I move this over so you can see it, is it uses the Blackboard API, runs some, I should point out, the first thing it did was actually using some system code on the Mac, and I made a Windows version of it also that automatically calls this thing and pops up a window. After that, everything is Python. So what it does is uses the Blackboard API in some Python code in order to connect to Blackboard, get the information from my account, download it onto my computer, so it's offline locally on my computer, and then build this HTML dashboard with the CSS in there to make things look nice. And this is now entirely offline, and it's the information that is current in my Blackboard account. What I'm showing you right here is for fictional students, so there isn't actually student information, but it shows me right at the top, here are missing assignments from whatever was recently due. Everything in here is clickable. So if I click on the little red X here, it pops up emails that are pre-populated with the details for that student that I can click send, or if I want to make some changes, I can make changes to it, or I can click on that just for a single student to pop up the email from a single student. I can click to look at that particular assignment, or I can click to look at it by student instead of by assignment. I also made it so that any code files that are submitted, it also creates a version where any comments are scripted so that inside of that file, I now have this that I can just with a single click bring up in order to interview the students about it, in order to make sure that they understand the stuff that they're putting inside of the code. And inside of here, I think it's just super cool that everything is very interactive. I can click to get whatever view I want, and I can click inside here to get whatever, and this is 100% offline. So that was the first thing that I did, and found that, man, these systems, when it comes to creating HTML, it's really good at it.
Okay, let me buy those.
The way it does this is wrote Python code that creates the HTML and CSS to build all of this on the fly interactively each time that I download something. So that was the first thing that I did, which blew my mind. It's like, holy crap, that is. And then the second thing, which blew my mind even more, and so for this second thing, first I used Google's version, and it kind of stunk. Then I tried it using Fable from Anthropic, and it did a really good job. So this is a paper that basically I vibe authored with Fable, which is the super smart model from Anthropic, and did a lot of going back and forth with it. But you can, I'll post in the chat the URL on the physics archive for this, but I was blown away at what it could do. And in the hands of students, there's lots and lots of power here that can be used for both good and evil in lots of different ways. And the last thing I'll just mention super briefly is the latest thing I've been doing is building what I think is a pretty cool app for iPhone running on iOS using Swift and Swift UI, which is Apple's languages, which I have never written a line of. However, you can build apps without writing a line of Swift or Swift UI. So I will stop right there. And who is up next?
Walter, I think, is on deck if you want to come up.
You all see me? Yep. Okay. So I want to kind of do two things. The first one is to tell you about a remarkable sort of thing that I did this summer, which is I'm a lattice gauge theorist by trade. We have a professor in our department who is working on lattice quantum gravity, and I am his code monkey. And I'm in charge of maintaining the code and coming up with algorithms to make it go faster, which is quite challenging because of some features of the calculation. And one of the things, so I have a computer at home. I'm in my office right now on my laptop. I have a computer at home that is doing a bunch of simulations. I have Claude Code running on that computer, and I am able to control it remotely by the remote control feature in Claude Code. So one of the things, I'll tell you another story, but one of the things that is remarkable to me that this has given me a huge productivity boost in is I can pull out my cell phone and tell my computer at home to do things. I can literally be walking around the streets of Pasadena while I'm being squawked at by parrots at the AAPT meeting, pull up my cell phone, check and see how the Markov chains are doing, ask Claude to write me a new algorithm or to try something or to do anything I can describe, and it can do that and then report back to me on my phone. Now, for a bit of fun, I asked Claude to whip up a brief slide deck on its perspective on this project. I could tell you about it, but given that this thing has been working with me all summer, I said, well, hey, Claude, why don't you write the slide deck? And it said, okay, I will. So let me share my screen now. I got to click a few buttons here. This is the one I want to do. Now, you'll notice that this is, what you're looking at here is actually the web interface to Claude, because Claude Code here is running on my computer at home, and I'm connecting to the Claude Code session on my home desktop using my laptop in my office. And so this, what you're seeing on the left is my conversation with the Claude model. And on the right is the slide deck that it made, just for funsies. So what has it said about what it's doing? Well, it has described, all right, we're doing lattice quantum gravity. We're summing over all possible shapes of spacetime. And down at the bottom, just because it wants to be extra, it has given a little bit of real-time monitoring data for the Markov chain run that it is supervising. Here's the action that it's simulating. And even a little, it's hard to see here, but a bit of phase diagram showing the phase transition that we are seeing in the data. It has an interesting perspective on collaboration, right? Again, I told Claude, you described the project. And it said, here's the problem. The code worked. It was sitting here making real physics, but we all have other jobs. I'm a teaching professor. During the year, I am swarmed by students. During the summer, I am working on PICUP things. I have a family. And, you know, it's given a little bit of snarky text, 3 overlapping documentation trees, each describing the code 2 refactors ago. This one I'll tell you about in a minute, what the fermion determinant that was too slow. And the fact that a bunch of lived wisdom lives in people's heads. And it says there's really no path in for a new contributor, right? Because most of the things are just things that me and Jack Liho know. And I love this snippet down at the bottom that Claude wrote. It says, this isn't the criticism. It's what happens when the people writing the code are world-class physicists and software engineering is the tax they pay to do physics. My git commit messages suck because I'm always thinking about the next thing that I have to do rather than being a software engineer whose job it is to write careful documentation. And here's Claude's slide about the human contributions. It says, what the humans bring is judgment you can't grep for. These models are trained on lots of published papers. It knows who PICUP is, doesn't know who I am, but it knows who Jack Liho is, my collaborator. And the comment here is that what we bring, what the humans bring to this is a lot of judgment about, hey, that looks wrong. And it turns out that Claude hasn't just worked on one code base, it's worked on 2. This description on the left is the thing that's actually going to production. You can read about it in Physical Review. And this started over the summer with me noticing that code running on my computer was running out of memory. And I said, hey, Claude, I don't have time to figure out why this is running out of memory. It doesn't feel like it should be using this much. You go figure it out. And it was very good at that. And then I said, hey, wait a minute. There's this great remote control feature in Claude Code. Maybe I can dictate software engineering to my phone or type in English on the console and let a tireless robot code the thing, test the thing, supervise runs, show me plots on my phone of how it's doing, and let me guide it and correct it. Also found some bugs that it's talking about, but the big one is it is sitting here supervising runs on a workstation at home, and starting hopefully this evening, it will start supervising runs on a cluster. Now, here's an interesting note here. I don't know if you can read the slides. It says, the lineage, per Walter and not my memory, of how this happened was I read about Project Glasswing in the news, which of course introduced Claude Mythos. Then when Fable 5 came out, I said, let me give it a shot, see what it can do. And the model here has said, I don't know about this. Walter told me about the existence of other Claude models 20 minutes ago, and I had to go look them up. So a really important thing to keep in mind whenever you're working with LLMs is they have no knowledge of anything that happened after their training cutoff, and they also have no knowledge of any other conversation you have had with them unless there's a record somewhere they can go look at. The other thing I had Claude do was when Claude Fable came out, which is the new super smart model, I said, hey, so the first code base I've been working on, this was written and kind of tended by Jack Lyho over many years. He learned C++ just to write this code base, put a ton of work into it, and I've kind of come back later as his code monkey. But then I said, hey, Fable, I want you to just, you're supposed to be super smart. Build me a Euclidean dynamical triangulation Monte Carlo code for quantum gravity from scratch. I want you to use degenerate triangulations because that's what we do, but I'm not going to give you any guidance. Just go do it. And it was remarkably clever. It designed its own tests. It ran its own tests. It did proofs of correctness. It did all of the things to make sure that it didn't make a mistake. Now, it did make a critical mistake in data analysis, which is a mistake that humans often catch by looking at graphs. And I warned it away from that. But basically, it reproduced years of software engineering by Jack in a day. The most useful thing that Claude came up with, and I'm going to stop showing you slides in just a minute. I'm showing you these slides. Again, these are robot slides. These are not my slides. I said, hey, where's all my memory going? I have to go feed the kid. You go figure this out. And Claude Fable looked at it and said, hey, you're running out of memory because there's actually a theorem here where you can reframe this. We're trying to do a matrix determinant, and you can actually rewrite this matrix determinant in another way, which ought to use less memory and also maybe goes faster. And it turns out it went shockingly faster, like 1,000 times faster. There's some performance data down here, which I think you can read over the screen share, that the thing we were doing before took about 2 minutes, and after this fix, it took 120 milliseconds, and also used way less memory. And Claude put together some mathematics that was known from since the 1940s, kind of obscure mathematics, with thinking about the graph theoretic framing of the determinants that we were trying to do, since they're sparse matrix determinants, and put together these two unrelated ideas and proposed this way to fix the code up, which is it's a factor of 1,000 in the performance critical path in our code. And this slide, I actually iterated back and forth with Opus. You can see the text on the left. Another thing that these models, there's an interesting thing. There's two fallacies, right? One of them is thinking that AI is completely unreliable and makes mistakes all the time and just hallucinates bullshit left and right. That's not true. The other fallacy is thinking that AI is infallible and super smart and never messes anything up. AI screws stuff up all the time, but so do we. And one of the things that the model is talking about here is it's saying it made a bunch of mistakes in this collaboration while it was supervising these runs, right? Because it was supervising runs on new code that had never been run before in Anger, that it helped write using algorithms that had never been tested to explore regions of phase space that were not well understood. So there was a lot of exploration going on when doing this, and there were a bunch of false alarms. It made mistakes. I made mistakes. And the important thing is the middle ground here of AI screws up stuff and you have to double check what it does, just like humans screw up stuff and you have to double check what it does. So that's kind of the story of this collaboration over the summer. I'm going to actually now get rid of this tab and say, can you regenerate? So let's see, you can see my Claude Code shared here. Can you regenerate the dashboard plots, all the interesting ones for the runs you are supervising, and give me a brief update on how they are doing. Then reduce the weave auto spacer offset by a factor of 3 using the live tune feature. So I just told it to do something, typing into my laptop in a web browser, giving it instructions for what to make my computer at home do. While it's thinking about how to do this, so let me kind of explain what's happening here. I should say this is part of the live demo at the workshop too. Now, it's not going to get this message until it's done with the thing that I've just asked it to do. But what's happening here is the text that I am typing in is going into the harness running on my computer at home. My computer at home is sending that text to Anthropic's data centers, which are constructing from that text and all the previous context, the knowledge it has about these simulations, what commands it would like to run on my terminal. So it's doing this, and I can click here, and these are all the bash commands that it's running on my terminal, which are things to look at data files and make some figures. That's going to take a little bit for it to do that. But when we have that, it will give us a status report. So these commands are running on my computer at home. The output is going to Anthropic's data centers for the model to then decide what it thinks about it. And then in a minute, we are going to get some figures here. It says, hey, this is a live demo. Great. It's making some figures. I had it restart the run today, so it's got to restart something. So it's sitting here thinking. While it's doing this, I'm just going to scroll up and show you just pieces of this conversation. Here are some from before. So this is, done. I think this was done while I was in Pasadena, actually. I said, hey, I would like you to generate me a figure showing such and such and such. It has said, hey, okay, I can do that. Let me render it using Python. Now let me look at it. And this is something that now both the model and I are able to look at that tells me how things are going in the run. And now we have the same things. So we've got here, this is the new one, right? Which is like the old one with a little bit more data tacked on the end. There's this guy, which it should look like noise. And then there's this guy showing we're right at a emerging phase transition here. So I'll stop here, but this is the sort of workflow I've been working on all summer while I've been doing pickup things. I will end my screen share here and people can ask me questions later.
Thank you, Walter. Jay, were you ready to share next?
Sure. Can you hear me?
And Jay, we can't actually hear you, not on the presenting area. Yes.
All right. Very good. So I'm Jay Wang, I'm UMass Dartmouth. Like most of you, we know AI. We've used AI, and I have, done AI coding, but previously through a chatbot. So it's only, I think, through the workshop planning that Larry says, well, have you tried the agentic? I said, no. You really should try it, the cool stuff you can do. So I said, okay, I'll go give it a try. And fortunately, my son is a data scientist and or / AI engineer. So he's been using agentic coding for since last year. So I said, Adam, can you give me a crash course on agentic coding? He said, sure. So one afternoon, we spent together, and so I'm going to show you the product. Okay, so this is the product is a HTML file. It's in the shared folder. I think Larry created, but I'll just post the link in the chat window. If you can, try it if you wish. Okay, so I'm going to share the actual product. If you open the HTML in your web browser, this is what you see. Okay, so this is the result of just one prompt through Cloud Code. The prompt is that help me build a 3-body simulation. Okay, so that's it. And then what happens is that a series of prompts from this Cloud Code, where you basically say yes or no, depending on the privilege you set, permissions you set. So now you can see that this simple sentence, right? That help me build a 3-body simulation is pretty general, right? Pretty loose. And so you can mean, gravitational 3-body systems. You can mean atomic 3-body systems, right? It can mean anything. So after a while, much like you saw through, Walter's command line window, it built this thing here. And it is initially just picked this HTML format. And it built this user interface as well. So right now you're seeing figure 8, 3-body, planar 3-body motion. Okay, they are bound gravitationally. So we are pretty familiar with this. It's stable configuration. And it also did Lagrange triangle, right? So what this is again, 3-body that always moves in a circle that is the equilateral triangle, okay? And then the other configuration shows with a star plus 2 planets, okay? And so the last one is this chaotic motion, right? So you have essentially, if I sort of lower this, reset this, yeah. So 3-body gravitational systems, as we know, they are inherently unstable, okay? So this will just start. And it's really impressive in terms of the, certainly the, the configuration is picked, right? But also the user interface made. So after this, and then we dabbled into a few other things, right? We said, okay, build this simulation in Python. And again, went to, do this in Python. And I have a Python code that actually runs much like this one here with the same similar user interface. Now, my experience has been that, AI is certainly very impressive already if you just, ask to do some code through this chatbot. But this agentic coding is really something else, okay? Now, you can do further iterations on this. For example, if you look at the upper right of your window, it says the energy drift. So the default thing it built was just using RK4 and wasn't conserving energy. So then we went and said, well, can you find a energy conserving algorithm, to run the simulation? And it did immune to find, to use this energy conserving, algorithm. And we did a couple other things. So I think you have to kind of, you have to try this. Hopefully through the rest of the workshop, to understand the power of this. Now, where and how we could use this in computational physics, I think that's the thing we are gonna, the workshop, we're gonna discuss that. So that's all I have. So is anyone after me? Larry?
Hey, yeah, I think I'm gonna show off some things. So thanks,
Okay.
Jay. I don't know if there were any questions for Jay or great. Okay. So I guess what I wanted to show was one of the things that I've been discovering recently. Although Steve mentioned at the very start how he and Todd and I have been using the Claude Code for our work on the trinket development work. It's allowed us to add a lot of features to that, and that's generated a lot of new code and helped us test all that and help us deploy it so that you all can hopefully use it over the school year. But one of the things that I've discovered along the way is I've been using the AI tools to help me with other like troubleshooting sort of things, or debugging, or just really, I guess, fixing my misunderstanding of some code related things. So it's not necessarily always like developing new code, but it's getting help with some stuff that I maybe had started or had changed since the last time I'd used it. And so I'm going to show you a few things that I'd use it for. So let's see if I can get this to come back up. All right. That was the wrong window. There we go. Okay, so here's my Claude desktop, and actually this is the most recent thing that I did. One of the things that I feel like I know enough in principle, but like I'm not super quick with the commands always, is working with GitHub. And so over the summer, I had 2 students working on a project with me in the lab. We're constructing, you can see here in the prompt that I gave it, we designed and constructed some ultrasonic transducers for use in physics laboratory classes. And this is a project I'm pretty excited about. At the very end of our time together with the students, both of them, like they put some documents together. One of them, we had a shared folder on OneDrive. And so one student who was working primarily on the lab activities, she put all of her files in there. And then the student who was working primarily on the CAD work and the 3D printing and the assembly of all these little transducer objects, he put everything together in a GitHub repo. But what he didn't do is he didn't write the README for the GitHub. And so I said, I described what was in the repo, and then I said, hey, please like write a draft of the README. And so it ended up doing that, and I was really impressed with how this README came together. I need to proofread it more for the specifics to make sure everything is correct. But at the very end, it said, look, I don't know who the authors are, and I don't know what license you want to use. So those are to-dos, and I'm going to need to like go through and update that. So that saved me not. I could have written a lot of this, but getting this nicely formatted with the markdown that GitHub uses, that saved me a lot of time, so that I have this nice like table and stuff like that. So I'm kind of excited about that, and that repo will be updated soon. In fact, I could, I could say right here, I'm going to close this. Since I'm not always great with the syntax for GitHub, oops, to try to make it so I'm not blocked. Okay, so I'm going to say let's see. Let's go ahead and update the repo on GitHub with this draft. Yes, I want to trust the workspace. All right, so it's probably going to prompt me to do something. One of the other things is that like I'm pretty good with GitHub now, or with Git, I guess, and pushing to GitHub, but I don't always do it cleanly. So if I feel like I haven't spent a lot of tokens, I go ahead and just ask Claude to do all the pushing to GitHub. All right, well, that's running. I want to show you one of the other things that I did. Yes, okay, it's going to ask me something. Let's go ahead and commit straight to main. And oh yes, I forgot to add all the lab activities. So it asked me to do those. So allow this, and it will make a nice commit message for me, which is kind of nice. All right. So while that's thinking, the other thing I wanted to show you is I had a different set of students who I'm not even necessarily working with them specifically. They're working with a different faculty member, but they're doing some field recordings with some audio recorders around our campus. We have a natural area, and so they deployed like 8 different audio recorders to record all sorts of things. That they're going after birds and insects and bats, and they leave the recorders out for like days or a week at a time, and so you get gigabytes of audio recording that comes back. And the question is, well, how do you go about identifying what birds have been recorded? And it turns out that there is some software out there that will help you do that. And I had used that software before, so these students came to me to ask how to work with that. And so it turns out to be the tool is called BirdNet Analyzer. Okay, this is from Cornell University. And one of the things is that if you tell BirdNet Analyzer like where you did the recording, latitude and longitude specifically, and the date that you did the recording, it has some routines in there that help eliminate like species. So we are near Chicago, and so if I tell it that we're near Chicago, it will not. It will assume that it is not going to get any birds that only live on the coast, for example, right? And so that's kind of cool. And so I was having trouble getting this to work, and I think I ran into basically 2 problems. One was that I think that since the last time I used BirdNet Analyze, I've switched computers. That was one of the problems. And so switching computers meant updating the software, and I think that there was slight differences in the syntax. And so what I thought was really cool about this is that it gave me some suggestions for how to run this. And so I tried running those on my computer. And let's see here. I asked it for some variations on how to run things. And then, actually what I did is I said, go ahead and run it. Just run this thing for me. And so it tried to run, and it was like kind of getting stuck at some point. And so I said, how's it going? Because there was no output that was coming out, and then that's when it told me, oh, it crashed, and it was my fault. And so it restarted everything, but then it learned that my college had installed some I don't know, software that sort of prevented the original thing from running. And since that happened, I'm trying to find where it is, it gave me an alternative way to run the thing. So after I did the alternative, here's the access denied. This is where it learned that the college is preventing some things. So it says block executable files from running unless It's enforced by our IT policy. And so there's an alternative way that is not blocked. And so it gave me this alternative way, and I was able to run that. So I thought that was a really, really nice way. It's a little like, I find this to be a little like the search engines, just going to Google and like, okay, I have an error, I'm going to Google it, right? And but with the AI tools, you're putting in the error, and then it's able to test things, assuming you let it test things. And then that's a lot faster cycle of going through, well, there's an error, how do I get around that error, and then getting to the next step, and eventually getting to a point where you've completed the what you want to, the task that you're trying to do. So let's see this thing. All right, so it looks like it made the commit, it did the push, and it's also given me some things that I need to follow up on, including the editing that README file to update those, the author and the license that I want to use. So I'll come back to that at some point and probably do that on my own. I'm trying to think of, this is another example of, I was using, a long time ago, I was playing around with this, this library called Python Tech, which is a way to put Python code inside a LaTeX file so that if you use it to write an assessment, like a quiz or an exam or a homework, you can have, you can have code in there that is executed, and so you're making calculations, or you can randomize questions, so you can reproduce things. And so anyway, I was playing around with that, and this is another example of where I haven't come back to this for several years, and so I was like, well, I want to try getting back into this. And so I had Claude help me check all the existing files that I had, and also try to help me author some new files and help me check the status of things. So here's what here was the original prompt. This folder contains several tech files that are assessments for physics classes. They were originally written with the Python, that should say Python Tech library. Please check to see if this computer has LaTeX. Oh yeah, I didn't even know if I had LaTeX on this computer, because again, this is a new computer since the last time I had been using it. And so it helped me troubleshoot everything to get to a state where all of the files were checked and there were no bugs. And I thought that was just really, really cool that I could do that all basically from the Claude code console. And then, when I was at the bottom, basically, I'm in a position where all of the files are rendering completely, and so I can start doing new assessments for the fall semester, basically. So yeah, and also I guess Larry showed off his little integration with Blackboard. I'm not nearly as far as Larry is, but I did something somewhat similar. I asked Claude to help me actually at the Slice event. Kelly shared a set of instructions for the how to set up Claude and Canvas to work together. And so I took the document that Kelly had shared with all of us, and I put it into Claude here. And I said, hey, I just basically want to follow these steps. Help me do that. And so now I have a MCP that is able to help me interface Claude with Canvas. I'm looking forward to using that much like Larry did. So anyway, those are some ways in which I sort of started with things that I kind of had a vague idea of where I wanted to go, but used the AI to help me get through it a lot more quickly.
Thank you very much, Andrew. Great timing.
Larry's muted. At least I can't hear him.
Am I muted now? It doesn't say I'm muted. Can you hear me?
I could hear you. I could hear you, Larry.
Okay,
I
good.
don't know.
Okay, thank you. So a couple of quick reminders. One reminder is that in the info board,